We are on question number 13. It says, as observed from the top of a 7-meter lighthouse from the sea level, the angles of depressions of the two ships are found to be 30 and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, we have to get the or find the distance between the two ships. So first, what we need to do is to make the base. Say I am making the base here, considering, say, now, let's say I make the base here, and then I'll make the tower or the lighthouse in this case. So this is the lighthouse. From these 2 points, from this point, there is a angle of depressions forms over two ships. So let's name this. Let's say AB be the lighthouse, this being 90 degree. And let's take 2 points, say C and D. These are the points where the two ships are there. And then there is an angle of depressions formed over here. And these angle of depressions formed from the top of the tower, which is A. So let's say this be the angle of depression. And let's say the other one I'm drawing it. So this is the second angle of depressions. You should know that while making angle of depressions, it is necessary to draw a horizontal. So I've drawn this horizontal. Right. Now, what are the angle mentioned here? The angle of depressions is one is 30, another is 45 degrees. So we can take this smaller as 30 and the larger as 45 degree. Further, we can see here that by using alternate interior angles, I can write this as 30 and this will be 45 degree. We also know here the length of AB and how much it is given here according to question. It is 75. The length of the tower is 75 meter. What we have to get finally is the distance between the two ships. This is what we have to get. This length DC is what we have to get. So for that, we are going to apply the trigonometric ratios into triangle. So let's say if I apply trigonometric ratio in the first triangle, the first triangle here is, we are taking the triangle ADC. So in triangle ADC, we can apply tan here as we need a relation between the perpendicular and base. It's 30 mentioned, so tan 30 is equal to perpendicular, which is AB, over the base, which is BD. Tan 30, which is 1 by root 3, is equal to AB, whose length is given as 75. BD is what we are looking to find out. So by cross multiplication, we'll get this as 75 root 3 meter. Now, once we get the length of this, now we'll take the another triangle. So I'm taking, next I'm going to take the right triangle as ABC. So we'll write in triangle ABC, we'll take tan 45, and that is perpendicular, which is AB again, and BC as the base. Tan 45, whose value is 1, that is equal to AB. We know the length of AB, so we can replace AB with its length, that is 75 meter, over BC. With cross multiplication, we'll get BC is equal to 75 meter. Now, as we discussed earlier, we have to get this length, and that is DC. From the figure, it is clear that we can get the length of DC. I'll do it here. We can get the length of DC, and that can be calculated by, we can calculate DC. Let's say, yeah, the length of DC, just a second. The length of DC, from the figure, it is BD minus CD. From this figure, you can see BD is 75 root 3 minus BC, which is 75. So you can take 75 as common. You can take 75 as common. So it comes out to be root 3 minus 1 meter. And that is, should be our final answer. This is the length of the distance between, not the length, the distance between the two ships. That is what we had to calculate.